Hello, I'm Mr. Bob, and welcome to my Geometry Review video series. This video covers Chapter 12, Section 1, titled Reflections. By the end of this video, you will have reviewed recent lessons describing the identification of isometries and finding reflection images. You will, by the end, be reviewing a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave your request at the comment section below. Please subscribe to the channel if you find the video to be helpful. Thank you. Okay, so let's start this review by looking at a few definitions. So a transformation. A transformation of a geometric figure is a change in its position, shape, or size. A pre-image. The original image is the pre-image. The image is the resulting figure. After the pre-image has been transformation, is the image. Again, the resulting figure after the pre-image's transformation is the image. An isometry is a transformation in which the pre-image and the image are congruent. A reflection. For better clarity, the definition of a reflection is being left for review until Objective 2 is presented. Okay, Objective 1, identifying isometries. A transformation of a geometric figure is a change in its position, shape, or size. When you assemble a jigsaw puzzle, you often move these pieces around, you flip them, you slide them, you turn them. Each move is a type of transformation. The photo below shows some basic transformations that you will be studying here. So you see, the first one here is a flip, where you've actually taken the jigsaw puzzle and flipped it from its laying on its face to laying on its back. Doesn't change the piece, does it? It's still the same piece. It just moved it, right? And how about the other one? Figure slides. So it's the same figure. It's sitting on its back, and you're just sliding it over a little bit and raising it up. That's a slide. Nothing's changed in the figure. It's just in a different location. And then there's the turn. The figure turns. So in this case, to say it's standing upright, and then we turned it 90 degrees clockwise, and it's kind of laying on its side. So you see, these are all changes in position, okay? Not shape or size, but position and how it's laying, okay? The original figure is called the pre-image. So the pre-image is where you started. The image is what you're left with. Okay, the resulting figure is the image, or is an image. An isometry is a transformation in which the pre-image and the image are congruent. These are isometries, these pictures of these jigsaw puzzle pieces. The puzzle never excuse me. The puzzle never changes. The pieces never change. They're just in different positions, okay? Each transformation above is an isometry. Does the transformation appear to be an isometry? Explain. Okay. The answer to this has to be no. And why is it not? Because an isometry is you can you can slide it, you can flip it over, you can rotate it. If it was in a 3D world, you could pull it off the paper, put it back on the paper. But the pre-image is smaller than the image. So we increased the size. These are not congruent figures anymore. So the transformation involves a change in size, right? A change in size. The sides of the pre-image square and the sides of the image are not congruent. Okay? Okay, example 1, you're going to check your understanding. So problems A and B. The piece at the bottom here is an extension of the review, but it doesn't have to do with the actual questions in the example. So why don't you stop the video and try and just or answer however you want to, or look at them and decide right now. I'm assuming there's not a whole lot of stopping you have to do to resolve this. And I'm assuming you've done that, you've thought about it, and you know what you're thinking about these. So does the transformation appear to be an isometry? And then it says explain. So the first one is the pre-image, or are the pre-image and the image congruent? If they are, even in this case, it flipped, right? We went from the pre-image has now been flipped up onto its face or its back or whichever way you want to look at it. Yes, it is an isometry. And it was a flip was involved here. We haven't talked about flips, I don't think. Well, we did do a flip. The very first picture was a flip of the puzzle piece. So then the pre-image and B, the pre-image and the image, are they the same size? Yeah, it looks like they're probably the same size. What happened to them? All that's happened is we've moved it, right? The image has not changed in size. So in B also, this is, yes, it appears to be an isometry because it just appears to be a shift or a slide in the picture. Okay. Then it says at the bottom here, a transformation maps a figure onto its image and may be described with arrow notation, or with prime notation is sometimes used to identify image points. In the diagram at the right, K prime is the image of K to the shift from K to K prime, right? So if you look at it, you see here we have triangle JKQ to show the arrow for the shift that we're talking about here. This is an image being mapped onto J prime, K prime, and Q prime. In this case, what was it? It was a flip across some center line. I don't know where the center line is. We're going to say that it was a flip somewhere down through the center here. Hopefully I can do a straighter line someday. But you get the idea. It's flipped over the center line. And then there's also, they could show the triangle JKQ maps onto triangle J prime, K prime, Q prime. Basically, it's the same thing, showing the flip, and they're saying it one image, pre-image maps to the new image. Notice that you list corresponding points of a pre-image and the image in the same order as you do with the corresponding points of congruent or similar figures. So, of course, what they're saying here is that if we're calling this K, and it's the closest point to this line, then this is K, right? You see it. J is over here, up at the same height over here. They're like distance measurements apart, right? This is at the bottom, right? And it's Q is at the bottom. So you could going from the inside, you go K, J, Q, or in fact, they do J, K, Q, J, K, Q, or J prime, K prime, Q prime. It's important to keep the order when you're talking about these triangles and any figures that we're dealing with. Okay, example 2, naming images and corresponding parts. In the diagram, the figure E prime, F prime, G prime, H prime is an image of the figure E, F, G, and H. So for problem A, it says name the images of angle F and angle H. Well, the image of angle F, we said right here, angle F prime is the image of F. Angle H prime is the image of H. So we have F right here, right? And here's its image. This is a slide we've gone on here. There's a slide to these two images, and we have this F prime now. The other one is H. Angle H is over here, and H prime is its image. How about list all pairs of corresponding sides? Well, we'll start off. The first side, EF. I'm going to change colors here, right? Let me change the color. So we start off with EF right here. And E prime, F prime is its image. I'm just going to draw the line actually instead of drawing around the circle. So these are pre-image. EF is the pre-image. E prime, F prime is the image. FG and F prime, G prime. FG goes down this side. FG is the pre-image. F prime, G prime is the image. Going down EH and E prime, H prime. EH over here. EH and E prime H prime. EH is the preimage, E prime H prime is the image. GH and G prime H prime. That's this little one here. GH from here to here is the preimage, and G prime H prime is the image. Okay. Okay, example 2 for check your understanding. It says in the diagram, NID changes to SUP, right? So there's a transition, a transformation, okay, that's going on. We don't know. We're looking at it. We'll try to figure out what we're looking at. But so it says check your understanding. So there's two problems. Look at these two triangles and try to answer these questions. Okay, we'll assume that you've done that. Name the images of angle 1 or I guess it's an I, angle I and point D. Okay, name the images. So first we have to find the pre-image. And in all these drawings, the pre-image is always the black lined image, and the blue lined images are the images. The pre-images are all black. So if we're looking for angle 1, which is right here, this is angle I guess I'll say. This is the pre-image. Which is the image? The image is U. Okay. So angle I maps to angle U. So we're going to say angle I maps to angle U. And then it says, and point D. Point D, so D maps to P. So you see how the triangle kind of rotates counterclockwise and slides into position. And now that you see that, it says list all pairs of corresponding sides. So it doesn't matter where you start, but we can start with NI at the top. So down right here, NI, that segment, it maps to, okay, SU. So it's S prime, or not even S prime, it's just SU, because we didn't use the same names for the, and then um, ID maps to UP, and finally DN, oops, that's an M, but I'll call it, I'm going to have to erase that. Sorry. Go back to this. DN maps to PS. Okay, that's the solution for that. Objective 2, finding reflection images. A reflection or a flip is an isometry in which the figure and its image have opposite orientations. Thus, a reflected image in a mirror appears backwards. In the diagram at the right, the triangle BUG is reflected in a line to produce a triangle B prime U prime G prime. Since the reflection is an isometry, triangle BUG is congruent with triangle B prime U prime G prime. So as you see, we look at this flip, and U and U prime, the preimage and the image of U are in the same spot. They're just on top of the line, right? You can't tell they're backwards yet, but when you look at where B is, you can see that now B is on the outside on the left, it's on the outside on the right. That means it flipped over, okay? And G is at the bottom. But we're looking at the front on one and the back on the other, okay? Using the diagram below, a reflection is a reflection in line R, and here's line R, is the red line right here. Line R is this line right here, if I can draw it. There my pencil goes. Look at that. There it is. Turn on the eraser. Get rid of all that baloney. And it's right here. There's line R, the line of reflection. That's R, reflection. So using the diagram below, a line of reflection R is a transformation for which the following are true. If a point A, here's A, right here, is on line R, then the image of A is itself. And that is that A prime and A, they're equal to each other. So if it's on the line, then it doesn't change. It doesn't move when you're doing a flip. It stays fixed. Okay? If a point B is not on the line R, which they're showing here, point B over here is not on line R, then R is the perpendicular bisector of B prime. So here you've got this point of B way out here, and we did the flip, and now the flip is on the opposite side, and this ends up being a perpendicular bisector right here. It actually bisects the line because we're flipped equally from one side to the other. The space between the line and the point does not change. It's just its orientation is different. It's on the other side of the chart or the graph or wherever you're looking at it from. You can use these properties to find and draw reflection images because you're going to look at a graph and say, oh, this point is over 2 spaces and up a space. And then over here, it's over 2 spaces the other direction, maybe up a space, or if you're flipping vertically, it could be over and down, or so you'll see it as we move forward. Okay. Example 3, drawing reflection images. The x-axis. So now they're talking about flipping across the x-axis, right? So coordinate geometry. Given the points A is equal to -3, 4, B is 0, 1. Those are the points on the graph. X0, Y1, or C, X2, Y3. Draw ABC, the triangle ABC, and its reflections image in each line. Okay, so we got reflecting across the x-axis and reflecting across the y-axis. So if we reflect across the x-axis, let's see, it says locate points A prime, B prime, and C prime such that the line of reflection is the perpendicular bisector of A prime, A prime, B prime, and C prime. Well, they're talking about the other triangle over here. So let's take a look at this one. We have our line of reflection right here. It's the x-axis. And as you notice, here's B prime, B and B prime. B is 1 unit up, right? B is 0, 1 in Y. So B is on right here at 0 on the x-axis. So it's 0, 1. That's where B is. C is at 2, 3. 2, 2, 3. Oh, sorry, I went the wrong way. C is 2, 3. Right here is C. Over 2x up 3y. And A is -3, 1, 2, 3, and up 1, 2, 3, 4. -3, 4. Those the points we're talking about. Okay. So now to flip this across the reflection line, we can do B prime, and we just look where X is, and we're just going to go, and we're not going to move on the x-axis at all. It stays on the x-axis. So we just read that in the previous slide. But in y-axis, we're going to go down. So we're going to be, the new point is going to be for A, what do I look? I'm looking at B. For B, the new point is going to be 0, -1. 0, -1. Okay. For C, it's going to be, we're over 2 and up 3. We're going to be over 2 down 3. So now we're going to be 2, -3. We don't move in the x. We're just moving in y at this point. And when you do A, I'll put A up here by the top. A ends up being what? We're -3, +4. So now we're -3, -4. -3, -4. This pen moves on its own. I have to figure out how to fix that. Okay, so now looking at the other one here, they want you to locate these points, the C prime, B prime, okay? And what we're gonna, it says here, the y-axis. So what we're doing is we're gonna be bisecting this figure and flipping it about the y-axis down here. Okay, I can do that in red too, just in case the blue isn't showing up that well. Let's try it in red. Oh, that's still blue. Oh, that's red. Okay. Oops. Down here. The line's down there. I'm going to erase that. But you get the picture of what I'm talking about. Let's try it one more time, see if I can get it straighter than that. That's a little better. Okay. So now, if we have point A and point A prime is over here on the right, A is on the left, A is 1, 2, 3 to -3, 1, 2, 3, +4. Same thing, -3, +4, but now we're splitting it and flipping it across Y. So now A ends up being +3, +4. So now what's changed is the A is changing. Where previously the Y changed, now the A is changing. So when you look at B, B goes nowhere. It's on the line of symmetry. And that's it. If it's on the line of symmetry, you do nothing with it. It stays the same. B equals B prime. For C, what we see is now +2, +3, +2, +3. We're moving across the Y, so now it's going to be -2, +3. So over here, C is going to be equal to -2, 3. B is equal to B prime. Nothing's changing. And A is equal to, went from -3 to -3, +4, -2, +3, +4. So now it's +3, 4. Where it was -3, 4 before. Okay? Okay, example 3, check your understanding. They'd like you to draw a triangle ABC of the example 3 above. That's included right here on the slide. You see ABC. And then draw its reflection image in line X equal 3. So we're not doing the axis, y-axis or x-axis. Now they want it x equals 3. Okay, so go ahead and try that. When you come back, we'll take a look at it. Okay, so I'm sure you've had time to look at it and come on back. So it says draw a triangle ABC of example 3. Here I've included it. And then draw its reflection image in line X equal 3. So how are we going to do that? Well, I started it for us. I just haven't drawn the image yet. This is the pre-image. I put the pre-image on, and you see I put on this graph, and with it on the graph, I placed our line right here at x equals 3. So that's a vertical line at x equals 3. And now we're just going to place our image. So how do we do that? Well, I've got A, B, C here. So the first thing we can do is we can take, so these are, oh, by the way, these are two per line, if you will, right? So, um, these aren't one each unit. There's two. So this right now would be a half from the line um, from the line x equal 3, because it's actually out to 1. This is going to be 1.5, okay, but the line is 2 each. So to start it, we're going to draw over here, right here, across from it. Here's going to be B, or excuse me, C prime, and then A is going to come across here from this line here. And what is it? It's 1, 2, 3 from the line. 1, 2, 3. As you notice, I'm halfway in between because they're 2 per. So this is A prime. And over here, B is up 1 and over 3. So it's up 1 and over 3. So right here. And then if you're going to draw your lines in, and this is B prime. So that's it. Now it's been reflected across x equals 3. Okay, example 4, we have a real world problem to solve here. So it says it's an engineering problem. Town officials in Waterville and Drayton are planning to construct a water pumping station along the Franklin Canal. The station will provide water to both towns. Where along the canal should they build the pumping station to minimize the amount of pipe needed? So they've given a picture here. So you see there's the town. The W defines Drayton, and the D over here is Watertown, okay? And P is the point where they're going to put the pumping station. They're trying to figure out where to place P. Now this diagram that's showing here is exactly where to place P, okay? And they'll talk about what they've done, but well, the problem is knowing where that point P is. It just doesn't show up automatically. You can't just draw a straight line out from W to L and use whatever that point is and get to know that it's the shortest distance, because it says here, uh, um, where along the canal should they build the pumping station to minimize the amount of pipe? So they're trying to keep this run here and this run here the shortest. So anywhere else, we're going to find out that you put P, you get more pipe. Okay, so it says you need to find point P on L. We just said that. L is the pipeline right here, where the line where the pumping station can be on the creek, on the canal rather, on L, such that WP, this first one right here, I'm going to do that in red now that I put yellow on it. WP and PD, that's over here now, PD, oops, are as small as possible. So it says locate D prime, the reflection image of D on or in L. So what they're telling you to do is you take, here's the line we're going to reflect across. So you've got this angle, if you will, here. And when you reflect this, it's going to come over and it's going to be this line over here. The angle is the same. And when you do that, you're going to see, they're going to say reflection image D and L. Because a reflection image is an isometry, PD equals P prime, P D prime. So this line, and they said right here, see right here, they got the hash mark, that these are congruent. The isometry is congruent. So flipping that over, this P to D prime is the same as P to D. And what we can see now is we see this straight line here. And it says, let's see, because the reflection is isometry, PD is equal to PD prime, and WP plus PD, okay, well, that's the original angle here, WP to PD is equal to WP to PD prime. Now, that's kind of, we've said it a couple times here. So, by the triangle inequality theorem, the sum WP plus PD prime is the smallest when WP and D prime are collinear. So what they're saying is that these two lines, legs of this triangle, if you will, are the shortest when the sum of those, okay, all those points would lie on the same line. When they're all collinear. That's what it says. The theorem, the sum WP plus PD prime is the smallest when WP and D prime are collinear on the same line. So the pumping station should locate at point P where WD intersects L. So they've shown you where the pipeline, this would be the length of the pipeline, and here's where they're saying it should be located. But it's not something you can easily point a stick at and say, oh, it goes right here, because if we're just going to, how do you know what if point P was down here? What if this is where, and you drew this is your your line from, it would be D to P, or P right here. And if that was the case, then W to P would be over here. Okay. Now these lines have changed. Are they the smallest, or are the sum of these two lines, these new ones? Let's do them with the blue again. The sum of these two lines, are they as short as these other two lines? Well, I have another slide here, and we can take a look at that and see. I tried to explain it a little bit. Hopefully it works. So I drew it out, and you don't have to think too hard on where the dots are. I think you already know where they are because we've been looking at them now. But I'm going to say that this is there. This is W, right? W. And this is P, right? P. And this was D. And this ended up being D prime way down here. And this is L, the line L. So I moved it for us. I said, what about this? I put right here a new P prime. P prime. I moved it. The pumping station is somewhere along the x-axis here. Okay. Right now they're saying that it's there. So from D to the new point, I drew a line, and from W to the new point, I drew a line. So it's the same concept, right? Now we're going to take D and mirror it across L, like we did the first time. First we took this line here, D, this P, D, and we mirrored it to get P, D prime. So now let's take it and mirror the new P prime D across to P prime D prime. Well, when you do that, you can see right now that it doesn't form a straight line, does it? It does not form a straight line. So if you take these lines and add them up, you can see since there's a space here, that space is filled in by the length of these lines. So the only way these lines can be the shortest is when these lie on top of those lines. So that's when, if you slide this P this way, and this gets closer and closer and closer till finally it's on top of it. And if you go this way, it'll start bulging out the backside and they'll be long again. So the only time these are true and the shortest is in this situation here when both P, W, P, and D prime lie on the same line and are collinear. I hope that's clear. I, I think I've explained it. If you have a question, write a comment and I will address it. Okay, example 4, check your understanding. The last slide in this section. So what does it say? You're going to go check this. Angela began to solve the problem above. I brought the problem under this page, you see it, by reflecting point W in line L. Will her method work? Instead of reflecting D, she reflected W. Will it work? And explain. Okay, let's talk about it a little bit. First of all, will it work? The answer is yes. It's the same thing. Y-E-S, it will work. Because whether you take and you mirror this PD to be PD prime and get a straight line from W to D prime, there's no reason why you can't do the same thing. You can mirror W across, right, like this, and you still get the straight line. And the length is the same because this piece here is congruent. It's an isometry, right? So since these are congruent, that's congruent. This line doesn't change. It has to be the same. So that's exactly why, because they're both about the point that is the correct point to put all the points in line. Same thing here. D, P, and W prime all lie on the same line. So therefore, that's still the shortest distance.